Okay, so this might seem like a big lesson. We're covering 3 lessons at once, but as we get into it, you're going to see that most of this is super straightforward. And the whole first part is really just some vocabulary that you need to be aware of. So a polynomial in general, I'll make us a little chart here. A polynomial in general is something that has a lot of terms to it. So if we are to write out a polynomial, an example might be 3x squared minus 5x y plus 2xz minus 4. All right, that's an example of a polynomial, and it's called poly. You might already know poly means many. So polynomial just means many terms. And for example, this example has 4 terms in it. Now, when they call it poly, when they don't want to count up too high, mathematicians are lazy. They give names when it's really simple, and then they just start calling things generic. So that's an example of a polynomial. If we kind of work backwards, a monomial, I'm going to spell this wrong. A monomial is something that only has one term. So examples of monomials may be like 15x squared y. Now, you may say, well, that's got multiple pieces to it, and it does, but monomials are all written together as multiplication. So this counts because this right here is just one term. And then a binomial, so now I'm going to count up for us. A binomial, because it says bi there, is going to have 2 terms. So that may be like 3x squared plus 4x, right? That there has 2 separate terms. And then our last example, we'll do a trinomial. And this is where they stop counting, and they just move on to polynomials after that. A trinomial is something that's going to have 3 terms. So maybe we have negative 7x to the 4th plus 2xy to the 8th plus 18. All right, that's an example of a trinomial because it's got 3 terms. So then the other part about polynomials is talking about their degree. So one way to measure a polynomial is by how many terms it has or how many pieces. And I hope you notice that the pieces are generally separated, well, not generally, they are separated by addition and subtraction signs. That's how I know that this binomial has 2 terms, 1, 2, or that the trinomial has 3, 1, 2, 3. Another way to measure polynomials is by degree, and the degree has to do with the exponents and how many, it's kind of a weird way to think about it, but it's like how many letters are in a given term. So for example, the degree of the first monomial that's been given here, there are 15x squared y, think about it like this, 15x squared y can be written as 15x xy if we expand that out. And think about how many variables there are there. There are 1, 2, 3 variables there now, which means the degree is 3. And I probably shouldn't write equals. Okay, so for monomials, it's pretty simple. When you start getting multiple terms, then your rule is, and you probably want to write this in your notes, you pick the degree of the term with the highest degree. So we have to count the degree for everything. So if in this binomial, I've got a degree of 2 and a degree of 1, because there's 2 x's in the first one, 1 in the second. So the final degree of this is just 2, because I picked the maximum. In this trinomial, I have a degree of 4 in the first term. In the second term, I have a degree of 9. There's 1 x and 8 y's. And in the last term, there's a degree of 0 because there's no variables. So in the trinomial, the degree here is, not 3, 9. All right, and in the polynomial, I've got 2 in the front, 2 here, 2 there, 0 at the end, which means my final degree is going to be 2. All right, there aren't going to be any more examples of how to do that. We will work on those in class. So if you're confused, I would really recommend you pause and rewatch whichever part of the video you need so that you know all of those definitions and how to count everything.
And then one more definition, or maybe 2 more, standard form. When we rewrite things in standard form, we just want to order them from greatest, and we're talking about the degrees, greatest degree, or you can think about it being the greatest exponent, to the least. All right, so for instance, A has 4 terms, and if I look at those 4, the highest exponent I see is this x to the third. So I start with negative 4x to the third, and then the next highest I see is squared, so minus 2x squared. Then I've got just an x, so plus 20x, and then I have something that has no variables, so a 0 degree, so that's plus 1. Notice that now my exponents decrease in order. I have 3 x's, 2 x's, 1 x, and then no variables whatsoever. That is what you call standard form. Now, when we have polynomials, we want to simplify them generally so that it's the simplest thing to look at, because a lot of times they can get lots of pieces going on. So what we're going to do is combine like terms. And remember, like terms mean you have the same variables with the exact same exponents. So on A here, even though they're all y's, even though every single one of these terms, one of these pieces has a y, I only care about the ones that have the exact same exponents. So I have 2 terms that have y to the third, which means I can combine those. And when I combine, I'm adding. So that's negative 2 plus 2. Well, really, those are going to cancel each other out. That's kind of a weird case, but they do cancel each other out. These other 2 both have y squared. And so this is like saying negative 8y plus 1, or sorry, negative 8y squared plus 1y squared. When we add them, we add the numbers. So negative 8 plus 1 is negative 7. But the term or the variables stay the same. So it's going to stay y squared. We're not going to add those. We just add the numbers. All right, let's look at B since it's got a few different letters going on. All right, so notice on B, what we want to do is identify ones that are exactly the same. So here I've got p squared q to the third, which means if I'm going to combine it with anything, I need another p squared q to the third. Even though this next term has a p and a q in it, the exponents are not exactly the same. There's a 5 and a 4, so I can't combine those. So I'm going to combine p squared q to the third, and I'm going to put a number in front of that just to make it easier to count. So this is 1 p squared q to the third minus 4 p squared q to the third. So 1 minus 4 is negative 3, and then think about the rest of it as just like a word. You're not going to change anything. So that's just p squared q to the third. And then I'm going to consider my next set. I have p to the fifth, q to the fourth. So I need another p to the fifth, q to the fourth, which I have, p to the fifth, q to the fourth. So I can combine these two. Negative 4 plus 3 is negative 1. P to the fifth, q to the fourth. And the biggest note that I want you to take here is that when you add, exponents do not change. When you add, exponents do not change. That is like the #1 mistake people are going to make throughout this whole chapter, so make sure you learn that now so you don't make that mistake in the future. All right, here's our lesson on adding and subtracting polynomials. Remember, polynomials are just algebraic expressions that have multiple terms in them. So today we talked about how many terms they had. There's 3 rules for today. So the first rule is that we need to distribute first. So if we have parentheses, we want to take care of that first thing. The next rule is that we need to combine like terms. Just like today, that means you have to have the exact same variables with the exact same exponents. And then the last thing, we want to write our final answer in standard form. So we are decreasing the exponents. For example, you would have like x to the fifth, and then maybe any x to the third term, and then x squared, right? You have to put them in that order, 5, 3, and then 2. So our first example, remember we need to distribute first, and I know that because I see parentheses. So
I need to ask myself what numbers are in the front of each of these to distribute. And if we don't have anything, that's just a 1. And you may notice when you multiply anything by 1, it's just going to stay the same. The same thing's going to happen on that second set, so I'm just going to recopy down what I had. 2x to the third minus 5x plus 1 plus 5 plus 6x squared minus 2x. All right, now my second step that we wrote down in our notes was we need to combine like terms. And because I want my final answer to be in standard form, I generally start with the highest exponent first. So I see I have an x to the third here. I don't have any other x to the thirds, so that piece is going to go first, 2x to the third. All right, now I'm going to move on to any x squareds. I see 1x squared. I don't see anything that goes with that, so I'm just going to say plus 6x squared. Okay, now I'm going to look for x's. I've got a negative 5x and a negative 2x. When I combine those, I get negative 7x. And now any of my terms that don't have x's in them, I have a plus 1 and a plus 5, which is going to give me plus 6. And I know that I'm done because when I look at my answer, I don't have any terms that have the same variables and exponents, so nothing else can be combined. And also my exponents count down. X to the third, x squared, a single x, which is really x to the 1, and then no x's at all, or x to the 0. All right, the second example looks similar from the beginning. In the very first set of parentheses, I again have a 1 that's going to distribute. In this second set, though, notice I have a minus sign. That means negative 1 is my number distributing. So 1, when you distribute that, those things stay the same because multiplying by 1 doesn't change anything. But when you distribute negative 1, it's going to change the sign. I have negative 4ab now. And then negative times negative becomes positive ab squared. You need to pay careful attention to these two signs right here. Make sure you understand how I got those. And then this at the end, this 6ab squared doesn't have any, a squared b, doesn't have anything to distribute, so I just copy it down, 6a squared b. And now you can kind of combine in any order you want to. I'm going to look for, since these have two variables, there's not really a way to do standard form, so I'm just going to combine as I see things that go together. So I have a 3ab squared and another ab squared, as we talked about in class today. This is plus 1 ab squared, so all together that's going to give me 4ab squared. I see another term out here that has a squared, and it doesn't have anything that can go with it. So I'm just going to copy it down, 6a squared b. I see another term that's got some variables. That's this negative 4ab in the middle, so minus 4ab. And then at the end, let's see, I've got this plus 2. It can't go with anything. So when I look to see if this is just to double check that I think this is my final answer, I'm going to look through and see, do any of my terms have the same variables with the same exponents? And the answer is no. And then that's really all you have to check here. So make sure that, and I guess you could make sure that you've used all of your pieces up here. We did this today, kind of checked them off. That's probably a smart idea. All right, our last example here is asking us to find the perimeter. This is a common problem that you're going to see in algebra. So you need to write down, even though this is a geometry standard, we're going to see it in algebra. Perimeter is when you add all the sides of something. So here, I want to find the perimeter, so I'm just going to be adding all of these things. So I'm just going to write it out as one big addition problem. 2x minus 1 plus 3x squared plus 4x squared minus 5. All right, notice I'm adding those three sides together. And then I want to look and just combine like terms. There's no distributive property to be done here, so I'm just combining anything that goes together. And again, we're going to do standard form. So I've got, looking at my x squareds first, that's 7x squared.
All right, looking at my solitary x's, or just x to the 1, I've just got one piece of that. That's 2x. And then looking at my numbers, -1 and -5, if I add those together, that gives me -6. And I'll double check my answer here at the end and just make sure that I don't have anything left that can go together. And I don't, so I know that I'm done.